angle.
Right, well, as I said to you guys, I think this one might be a little bit easier to get your head around, okay? So what we're trying to do is we're trying to divide this by that. So what I would be doing is dividing x squared plus 3x minus 4, dividing that by x plus 1. What's the first thing I'm looking at? How many times does x go into x squared? X times. Okay, so that's where I've put, it goes x times. That's what it's like in place value, if you can imagine that. X squared, x is in numbers. So x times x is x squared. Are we happy with that? X times x is x squared. X times 1 is just x. Okay. Now before, when we were doing division, what we did is we subtracted these terms. X squared minus x squared is 0. 3 minus 1 is 2x. Now, did I do anything else? Is that? Bring down the negative 4. Now what do I do? How many times does x go into 2x? That one go into that one there. Okay? X goes into 2x how many times? Positive 2 times. 2 times x gives you 2x. 2 times 1 gives you positive 2. When I subtract those, what do I get? Negative 6. What is it? What do I do with that negative 6? That's my remainder. Yep. That's my remainder. Okay? Everyone happy with that? Now, that's got a remainder of negative 6. Does that mean x plus 1 is a factor? If I did this division and got 0, what would it mean? It would mean that x plus 1 is a factor. Okay? We're going to use that knowledge later on, and I'm going to introduce you to the remainder theorem and the factor theorem, and it's basically just doing that there, trying to get remainders of 0 in a way. Okay? Who followed that? Okay. Next one. What am I going to do here? X cubed plus 2x squared plus x minus the 4. This is all divided by x plus 2. Is that right? What do I do now? X cubed divided by x gives you x squared. X squared times x gives you the x cubed. X squared times 2 gives you yeah. Like that. Happy with that? Is that right?
Yeah.
So subtract those out. What do I get? I get 0, don't I? Okay, I get 0. So what do? I bring down this x and the minus 4. Why did I bring down the x and the minus 4? Why did I? Okay. Because I'm trying to see how many times the x plus 2 goes into the x minus 4. Okay. To do that, I go, how many times does x go into x? 1. I haven't got any x's there, do I? Why do I not have any x's there? Because when I did my multiplication out here, I got 2x squared, which is why I cancel with those 2x squareds there. Okay. 1 into x goes x. 1 into 2 goes positive 2 times. When I do my subtraction there, I'm going to get another answer of, and that is, again, that is my remainder of negative 6. Okay. Can you see where we're going with that stuff?
Is that like as hard as you'll get, or?
I don't know, I haven't looked at the assessments. Okay. But just, okay, and just a little aside, remember, all we're doing here is a question like, First of all, what is that question?
36 divided by 4.
36 divided by 5. Okay. Now 5's into 30 doesn't go, so 5's into 36 goes 7 times. Remainder 1. Is that right? What is that remainder 1? Is that remainder 1 just?
1/5.
It's 1/5, eh? Why is it 1/5? What is it about the 5? What?
Remainder over.
It's because what you're dividing by, eh? So how can we write this again up here? We could actually write this remainder 6 as like that. Couldn't I? And I can write it over here, instead of being x remainder that, it's x plus 2. Okay?
So would you go like x squared plus 1 minus 6?
Over x
Like
plus
could that go in the okay.
Yeah. So what we're sort of trying to say is that this equation here eventually is going to be the same as those two equations are going to be quite similar. Okay? Why are they going to be similar? What's the difference between those two equations?
Like the factor of x plus 2.
Yeah, if I multiplied everything by a factor of x plus 2, what we would have is we would get that equation there. Okay? If I try to get rid of that denominator over there, I'd actually get x plus, I'd actually get this part of the left hand side. So, what I'm going to do now is have a crack at exercise